Okay, this question 7.1, we're given this situation and for part A, we need to determine if the range of the ship's radar is 8 miles, which is this line right here. Will the fleet be detected if it's traveling along this line over here? So the radar being 8 miles means, does that line ever go through this circle? In that question, basically, this is their line of sight. Is it possible that these two lines will meet ever? So will these lines, I don't know, there or down here, is it possible that this line that comes out of the 35 degrees will meet that 8-mile distance? So to find that, let's check this triangle. So let's assume it does and call this point B. And this is still our 35-degree angle. Just kind of change the diagram a little so it makes a possible triangle. So let's see if it follows the rule of sines. So I have sine of 35 and it's paired with side that is 8 miles long. And sine of B is paired with that side that's 15 miles long. And let's see. So now I want to solve for sine of B and see if this is possible. If it's possible to have this triangle, sorry. So I get cross multiplying, I get sine 15 times sine of 35 equals 8 times sine of B. Then divide both sides by 8 gives me the sine of B equals 15 times sine of 35 over 8. And that is 15 times the sine of 35 divided by 8. Which is greater than 1, which is not possible. So that means this triangle is not possible. Those lines will never meet. So, to answer in terms of this question, the departing fleet will not be detected by that radar. Okay. Then question B, if the maximum range is 12 miles from port, when is the fleet first detected? So now we're talking about this line being 12 miles long, and they want to know, when are these two lines going to meet? But this picture is a little bit deceiving because that angle that coming out of the radar ship is not fixed. What's fixed is, let's keep our black here, is the 15, that length of this guy is fixed. And the length of this guy is 12, not 8 anymore, but 12. And we know that this angle is 35. We don't know the length of this side, and we don't know the angle here or here. So that line could actually be more like this and still be 12. So where is that 12 that it will meet the other side? So that would make this angle B. So we don't know if that B is that obtuse one or that acute one. So it looks like the obtuse one would be a shorter distance though. So let's see what we get when we do this law of sines. So for part B, we do sine of 35. That angle corresponds to the 12-mile line. Whether it's this one or that one, we don't know yet. And that corresponds to see, what do we have? Sine of B. We don't know B. But we do have, actually we have side B though. So side B to the sine of B. So when is that going to give us the shortest length for this side over here? Okay, so sine of B is cross multiply. I get sine of 35 times 15 and then divide by 12 to get that. So B, now when I do the sine inverse, remember I'm always going to get the acute angle. So I'm going to have to manually find this angle here. This when I do sine inverse, it's going to give me this little acute angle. So I do sine inverse of this stuff. And I get 15 times, oops, sorry, I forgot the sine inverse. Sine inverse of 15 times sine of 35, close that sine, divide by 12, and then close the sine inverse. And I get that B is oops, not in red. 45.8. That's this little guy over here. But I'd rather have the obtuse one because that one's closer. So let's now see what is that obtuse option for beta. So we'll do, that's option 1, right? And then let's do in red, this little guy here is 180 minus that, which is, call that our B2, which is 134.2. So this guy is going to give us the shortest distance, right? So we're looking at this triangle now, because that's the shortest distance for the value we want right there, which is, I guess we'll call that D for distance. That's when they get caught. All right, so we have B, we have, we don't know this angle yet, do we? Oh, yes, we do, because with 100, right, so we can call that angle C. So C is 180 minus the other two angles, so minus 35 and minus the B we just found, which is 134.2, which tells me that that third angle at the radar ship is 10.8 degrees. Okay. So now I have this little guy, I have everything except for D. So I can use sine of, law of sines. I have sine of C, which is 10.8, across from that distance, which is D. And that could be, I could use either of those ratios. Let's go ahead and use the 35 to 8. I'm sorry, 12. Our distance is 12 now. And then solving for D, I get D equals 12 times the sine of 10.8 divided by sine of 35, which gives me 12 times sine of 10.8, close the sine, divided by sine of 35 equals D equals 3.9, and our unit is miles. So to answer question B, if the maximum range of the ship's radar is 12 miles, how far from the port is the fleet when it was first detected? So the fleet is first detected at 3.9 miles.